Okay, so now we're going to talk about graphing rational functions. Now on your test preview, you do have 3 problems. On your actual test, you will only have 1 problem. Okay, these are just a few different examples for you to practice. So, very first thing when we get to rational functions, we need to factor them. So on the top, we need 2 numbers that multiply to 12 and add up to 8. So that's going to be 2 and 6. On the bottom, 2 numbers that multiply to 8 and add up to 6 is 2 and 4. Oops. Okay, now before we try and cancel anything out, we need to look at our domain. Okay, we look at our denominator here. We know x can't be -2 or -4. Okay, and we figure that out just by setting each of these equal to 0. So, in our domain, we want to skip -2 and -4. So I'm going to go -infinity to -4, -4 to -2, and -2 to infinity. Okay, so you always find your domain first, and then we can simplify, find our reduced form, and do everything else. So now we can cross off that x plus 2, and all that's left is x plus 6 over x plus 4. Okay, so to find our wholes, we look at the one that we crossed out, which was our x plus 2. So again, set that equal to 0, you get -2. So our x value is -2 for our whole. Now to find the y value, we plug -2 into our reduced form. So I'm going to go -2 plus 6 over -2 plus 4. Okay, -2 plus 6, that's 4, over -2 plus 4 is 2, and 4 divided by 2 is 2. So we have -2, +2. Okay, and since that's the only one we crossed off was our -2, that's our only whole. Now we can look at vertical asymptotes. Oh, there's the bell. Okay, so now we can look at our vertical asymptotes. We always look at the denominator. Okay, so I'm going to look at x plus 4, and I'm going to set that equal to 0. Okay, and then if we solve that one, we get x equals -4. So that would be my vertical asymptote, x equals -4. Okay, now horizontal is a little different. We look at top and bottom, and we want to look at the degree on the top and the bottom. So I'm going to go to my highest exponent on the top, which is just the plain x. On the bottom, it's the x as well. Okay, since the degrees are the same, they just kind of cancel out, and we're left with their coefficients, which would be 1. So our horizontal asymptote here is 1. Okay, now x-intercepts, we look at the numerator. So I'm going to do kind of the same thing we did for denominator, but I'm going to look at the top. So we have x plus 6. Oh, geez Louise. X plus 6 equals 0, which gives me -6. So that means I have an x-intercept at -6, 0. Okay. And then our y-intercept, that's wherever x equals 0. So we're going to plug 0 in for x into our reduced form. So I have 0 plus 6 over 0 plus 4, which we know would just be 6 over 4. Okay, you can type that in a calculator to get the decimal. You can leave it and do 3/2. Either way, we get about 1.5. Okay, or 3/2. Normally, I am a big advocate for fractions, but with graphing, decimals are usually a little bit easier. So, 0, 1.5. Okay, one thing to note, vertical and horizontal asymptotes are equations. Okay, x and y-intercepts are points. Make sure you keep it that way. Okay, lastly, we have our end behavior, which again is just our horizontal asymptote. So we have 1 and 1. Okay, Now let's do our graph. So when you're going through the graph, I just kind of start at the top and I'm going to graph everything that we have. So starting with our hole. We have a hole at -2, 2. So I'm going to go -2, 2 and just draw a little hole. Next, vertical asymptote is at -4. So I'm going to go draw that one on there. Okay, our horizontal asymptote is at 1. We have an x-intercept at -6 and a y-intercept at 1.5. Okay, now this one's kind of nice because we can kind of see exactly what the graph's gonna do, right? On this right side, it'll go up and then approach 1. And then on the left side, we know we're gonna be in the negatives because that's where our x-intercept is. So we'll have something like that. Okay, and just remember that at the ends, you should be approaching your horizontal asymptote. Okay, you're not crossing it or anything, you're just approaching it, getting closer to it. Okay, that's the first one.